In this video, we'll look at how to use begin shape and end shape to string together a whole bunch of Bezier curves. The idea will be to make something like this. Here's an open Bezier curve that I've made out of a bunch of segments. I'll show you the knots on the handles so you can see where they are. And this curve might be used for something like a lunar lander game. So this could be a landscape of some sort. And we can tweak these things up until the landscape has just the feeling we want. We can make some little landing zones. Maybe we'll make this a little hillier. And then when everything looks right, we'll take those away. And this is the curve that we want to draw. This landscape is made up out of 3 Bezier curves. One on the left, one in the middle, one on the right. Of course, there are 4 points that the curve goes through, but each of those points has 1 or 2 handles, giving us a total of 10 points. So we have to hand processing all 10 of these points somehow to get it to draw the curve. Let's now look at the mechanics for handing those points to processing so it draws this nice landscape. In this picture, I'm showing 3 different Bezier curves put together smoothly. We saw this picture in an earlier video. I'll use this picture to give you the overview for the process, and then we'll go into the mechanics. The basic idea begins by numbering all of the points, of course. So the orange curve is going to be points 1, 2, 3, and 4. But now look at the green curve. The first point of the green curve is the same as the last point of the orange curve because they touch. So there's no need to repeat it. So point 4 is both the last point of orange and the first point of green. So moving on, the 3 points that we add to green are going to be 5, 6, and 7. Now look at the purple curve. Once again, the first point of the purple curve is the last point of the green curve. So there's no need to repeat it. We just number the 3 additional points. This captures the key idea in building up a big Bezier curve out of many segments. We first identify the first point of the first curve. That's point 1. Now we only have to provide 3 more points. In this case, points 2, 3, and 4. Point 4 does double duty. It's also the first point of the green curve, so we don't repeat it. We only have to provide the new 3 points for the green curve, points 5, 6, and 7. Again, 7 does double duty. We know it's going to be the first point of the purple curve, so we don't repeat it. We just give processing points 8, 9, and 10. This structure, the first point, and then a series of triplets, 1 triplet for each additional curve, is the basic idea. So let's see how we might use this. I'll move these up to the top and I'll put the picture back so we have a reference for it. As usual, we begin with begin shape and end with end shape. The first thing we do to get the ball rolling is we hand processing the first point, and we do that simply by calling good old vertex. This is our old friend from when we drew pictures with straight lines. This lets us give processing the first point. Now we want to give processing points 2, 3, and 4, and we do those with a single call to Bezier vertex. Notice that there's a capital V in there. Bezier vertex takes 6 arguments. XY, XY, XY for the 3 points that flesh out this curve. Now we want to draw the green curve. When we draw things in this style, between begin shape and end shape and using Bezier vertex, processing knows that the last point of the previous curve will be the first point for the next curve. So looking back up at the top, what it needs are points 5, 6, and 7. So let's look back at the code and call Bezier vertex again and hand it points 5, 6, and 7. Once again, it knows that the last point, 7, will be the first point for the next curve. Looking back up at the top, we can see what processing wants now are points 8, 9, and 10. So going back to the code, we just hand processing the points 8, 9, and 10. Then we call end shape, and we're done. The code we're looking at here is great if you have exactly 3 curves. But what if you want to draw something out of 100 curves? Well, of course, you want to wrap this all up into a loop. So let's see how to do that. Here's all the code in one place. Don't worry about it. We're going to take it one step at a time. Down at the bottom, we have our output window. This is where I'm going to draw our graphics. The first 2 lines create a pair of floating point arrays. I'm calling them X vals and Y vals because they're going to hold the X and Y values of each of our vertices. Of course, I'm just using short names. You can call these anything you want. In this example, both arrays have 10 values, but they can be as long as you need them to be to draw all the points for your curves. Like in previous examples, the first entry of x vowels and the first entry of y vowels are the x and y values of the first point. The second entry of x vowels and the second entry of y vowels are the x and y of the second point, and so on. The work of drawing the curve is wrapped up in this one function called draw one big curve, so let's look inside of it. Of course, the key things here are we begin with begin shape and we end with end shape. Those are old friends, so let's look inside. The first thing we do is we call vertex with the x and y values of the very first point. That's just x val sub 0 and y val sub 0. As I mentioned before, we're calling vertex, our old friend, just to plunk down this first point. Looking down at the graphics window, we're telling processing this is the location of the first point of the first curve. Now we're ready to start the loop. Looking back up at the code, here's the loop. The for loop has three statements between the parentheses. Let's look at them one by one. The first statement says int I equals 1. Okay, that says create an integer called I and start it with the value 1. You're probably used to most of our loops beginning with 0, but we're starting with 1 here because we just handed processing point 0 manually. The first time through the loop, I want to hand it points 1, 2, and 3. So I'm going to start at 1. Now let's look at the test in the middle. We're going to keep bumping I until it reaches the length of the x vowels array. It could have been y vowels. They have the same length. I chose x. The third statement in the for loop, all the way at the end, the update, reads I plus equals 3. We'll come back to that in a moment. But for now, I has just been created and it has the value 1. Let's now look inside the loop. Well, the loop has just one statement. It's a call to Bezier vertex. I've broken it up into 3 lines so it all fits on the screen. The first 2 values we hand Bezier vertex are the x and y values of point 1, because I has the value 1, and then we hand it the x and y of point 2, I plus 1, and then we hand it the x and y values of point 3, because that's I plus 2. That wraps up the call to Bezier vertex, and now if we look at the graphics window, processing says, oh, you've just given me points 1, 2, and 3 inside of a call to Bezier vertex. You must want a Bezier curve. So that's great. We've now drawn our first curve. We reach the bottom of the loop because there's nothing else there, and we go back up to the top. It's a for loop, so the first thing we do is we go to the right-hand end and we execute the update statement, which here reads I plus equals 3. I'm increasing I by 3 because I just used up 3 points. By handing points 1, 2, and 3 to processing, I now want to hand it 4, 5, and 6. So I add 3 to I. I now has the value 4. We do the test. Is 4 less than 10? Yes, it is. So we go back into the loop. Now we hand processing 3 new vertices, 4, 5, and 6, or I plus 1, and I plus 2 when I has the value 4. So looking at our graphics window, processing says, oh great, you've given me points 4, 5, and 6, and I remember to use point 3 because that was the last point of the previous call to Bezier vertex. Because we're wrapped up in begin shape and end shape and we're calling Bezier vertex, processing remembers to chain these little segments together. So I hand it points 4, 5, and 6, and it says, I know what the first point is. It's the last point of the previous curve. So there's our little skeleton, and processing draws the Bezier curve that goes through them. Well, now we've reached the bottom of the loop again, so we go back up to the top. I has the value 4. We go to the update statement. We add 3 to it. Now I has the value 7. And we test. Is 7 less than 10? Yes, it is. Back into the loop we go. Now we hand it points 7, 8, and 9. Once again, it remembers point 6 from the previous call, so now it's going to add points 7, 8, and 9. Just for fun, I won't make these line up smoothly, just to show you that there's no need for that. So looking at the graphics window, here are points 7, 8, and 9, and processing says, well, you must want a little curve through those, and there's the curve. Now we hit the end of the loop, we go back up to the top. I has the value 7, we add 3 to it, that makes it 10. And now we check its value. Is 10 less than 10? No, it's not. So we're done. We hit end shape and we're finished. We've drawn our curve. This little loop will work for any number of Bezier segments that you want to chain together. If you want the segments to chain together smoothly, make sure that the first handle of each new curve obeys the rules that we saw before. It has to lie in a straight line with the first point of the curve and the last handle of the last curve, and they have to be the same distance apart. I've just drawn an open curve. If you want this to be a closed curve, that's no problem. Just make the last point of the last curve the same as the first point of the first curve. Now the curves will touch, and as long as the handles on both sides of that first point obey the rule, the last Bezier segment and the first one will join together smoothly, and you'll have a nice closed curve. This is it. This is the general technique for drawing any number of Bezier segments as one big curve. So if we want to draw our lunar landscape, we can draw our sketch on a piece of graph paper, write down the locations of all these x and y values, and type them into our arrays, and it will draw this picture. Or, of course, you could use some sort of an interactive program like this one to design them interactively and make the curve you like by grabbing and moving it around until it looks just the way you want. Now you know how to draw a curve like this involving any number of Bezier segments.